Should you buy a mini mill or an old industrial mill? This is a question that I think a lot of us hobbyists have struggled with. I know I agonized over it, and I'm usually very impulsive. The tattoo on my butt proves that. So I wanted to make this video to cover the pros and cons of each, what I ended up choosing, how I got it working, what the actual costs were, how those costs compare to the alternative, and whether or not I'm happy with my decision. First, I should be clear about what I'm talking about when I say mini mill. I'm referring to the Sieg X2 style vertical milling machines that are sold with a bunch of different nameplates and color schemes. You'll sometimes hear that they're all the same, but that isn't quite true. More reputable brands tend to have better quality control and do some work of their own to make the machines better. There are also two major varieties of that mini mill design: tilting column and fixed column. Everyone hates the tilting column design, so you want a fixed column machine. In the US, that means you'll probably be buying from Little Machine Shop and getting either a Sieg X2D or a high torque model. If you've got the big bucks like Quinn at Blondie Hacks, you can go to Precision Matthews. I'll be comparing the Sieg X2D since it's the most affordable option from a reputable brand with a fixed column. The advantages of a mini mill like that are the small size, minimal weight, and ability to run on regular single-phase household power. They're also affordable for a brand new machine and have tons of documentation and aftermarket parts available. But that small size and low weight are also big disadvantages. Milling is all about rigidity, and mini mills simply don't have the heft to give you much of it. You can still do most jobs, but you'll be taking light cuts, and it'll take a long time, like trying to cut a plywood sheet in half using a Dremel. Used industrial mills are basically the complete opposite. They're huge and very heavy, but they have rigidity out to wazoo and are usually very powerful. A quick side note, Bridgeport is the only name non-machinists know, and they are great machines. However, there are plenty of other brands that are just as good or better, but that are much more affordable because they don't have that brand recognition. These used industrial mills are kind of intimidating because they take up a lot of space, they're really hard to transport, and they almost always require three-phase power, something that nobody has in their home. But those complications also make used industrial machines cheap. An old mill that costs the equivalent of, say, $15,000 new might be roughly the same cost as a new mini mill while being far more capable. And that's why this is a hard decision. Do you choose new and convenient or old and robust? I'll cut to the chase and tell you what I did. I went the old route, very old. I bought a Gorton 9J knee mill, which I believe was manufactured sometime in the 1950s, making it about 70 years old. I'll give you a tour of this machine and all its neat features, then I'll tell you what it took to get it running in my garage at home. From there, I'll go over the costs compared to a mini mill, and then my conclusions, which will hopefully help you make a decision for your own home shop. The Gorton 9J is an absolute unit of a machine. At the time, Gorton had a Gorton 8D and 8.5D, but the 9J was the biggest of the bunch. It measures about 7 feet to the top of the spindle motor and weighs in at something like 3,500 pounds. It is a big mill, and just getting it into my garage was an adventure, which I'll talk about in a moment. The size and weight make this machine very rigid, and it has a reputation for being able to chew through anything while maintaining precision. This is a knee mill, which means that the head is stationary. The table rides on the knee, which you can crank up and down on the Z-axis. The 9J also has a quill that you can move up and down in Z. Based on the handle locations and their precision, I think the designers intended for the operator to move the knee to the general vicinity and then use the quill for precise adjustments while milling. It has 31.5 inches of travel in X, 11.25 inches of travel in Y, and 14.75 inches of travel in Z. So I have plenty of room to mill just about anything. It has an absolutely gargantuan 5-horsepower spindle motor, which rotates the spindle via a belt and pair of pulleys, and more on that in a bit. The spindle has a Brown and Sharp number 10 taper, which was pretty unusual and tooling isn't very common these days, but the seller included a ZZ collet holder in the deal and I plan to mostly use that. And one of the best features is the built-in power feed through a mechanical gearbox. I can power feed either axis or both at the same time and can select from up to 12 different speeds, covering everything from rapid travel to slow milling. There is also a power down feed motor on the quill with full speed adjustment. That is perfect for boring. And there is a lever for quickly moving the quill like you might want when drilling. But getting this into my garage and set up wasn't easy. In fact, it was too tall to even fit through my garage door. So let's talk about how I pulled that off. Part of the reason that these old industrial mills are so cheap is because they're difficult and expensive to move. But I was able to negotiate with the previous owner to include delivery in the purchase price. I knew that it wasn't going to fit through my garage door, so I met the owner at his shop and we used his forklift to pull the spindle motor off the machine. That motor weighs at least 150 pounds, probably more like 200, and I wouldn't have been able to get it off in my driveway. The owner then used the forklift to load the machine onto his trailer on top of 4x4 boards and hauled it up to my house, which was about 20 minutes from his shop. His trailer drops pretty low and angles down at the tailgate. I rented a pallet jack from Home Depot and we got it under the mill, then carefully scooted it off the trailer using a heavy tow strap wrapped around the front of the trailer to keep it stable. With it off the trailer and on the pallet jack, we muscled it into the garage and dropped it onto a pair of 4x4 boards in there. Luckily, both my driveway and the garage are fairly level, so we were able to do that with just perseverance and a lot of sweat. It is also worth noting that you can rent a forklift and have it delivered to your house. That wasn't an option for me because it wouldn't fit through my garage door, but it may be an option for you. You may have noticed that I didn't say anything about getting the motor back on the machine. Don't worry, I'll come back to that. Before anything else, I wanted to get old Gordy cleaned up. She probably hadn't had a good bath in decades. First, I pulled off the old DRO, work light, and mist coolant system. I was hoping to use the DRO, but it isn't working. Probably for the best since it lacks the features of new DRO units. The work light was just gross, so I tossed it. And I'm choosing not to use the mist coolant system because I don't want to deal with air. And instead I'll just build a flood coolant system shared with the CNC mill that sits next to Gordy. With all of that off, I probably spent a good 15 hours scrubbing. This isn't a restoration and I wasn't trying to make it museum ready, but it looks a heck of a lot better all cleaned up. This is probably a good time to talk about the various motors and their power requirements. Since I removed the coolant system, there were 3 motors I wanted to get running: the spindle motor, the table power feed motor, and the quill power feed motor. As I mentioned, the spindle motor is a huge 5 horsepower behemoth. It requires 480 volt 3-phase power and cannot run on anything else, though some spindle motors can also run on 240 volt 3-phase. That was the case with the table power feed motor. It is also 3-phase but can run on either 240 volt or 480 volt. The quill power feed motor is a bit of an oddball. It runs on 115 volt DC power, which allows for speed adjustment via voltage. Now, if you've ever looked into converting single-phase power to 3-phase power, you know that it isn't exactly cheap or easy. That's especially true when the motor requires 480 volts, and it was especially true in my case because I didn't even have a 240 volt circuit in my garage. Just measly 120 volt outlets. In an attempt to save money, I had the brilliant idea to replace the spindle motor with a motor from a treadmill. I bought it on eBay and it's rated at 2 horsepower, running on up to 90 volt DC. I figured I could power that via a rectifier and get speed adjustment. I even went ahead and used my mini lathe to turn a shaft to mount the pulley. When I asked for advice on Reddit, everyone advised me against this plan, but I persevered anyway. And yeah, they were right. It didn't work at all and the motor started smoking almost immediately. While the motor was rated for 2 horsepower, and that is enough for most milling jobs, it was very much lacking in torque. I'm bad at the math, but I think it had like a 20th of the torque of the original spindle motor. On top of that, the treadmill motor is meant to mount horizontally. I had it mounted vertically with the very heavy pulley hanging from the shaft. The bearings aren't meant to handle that kind of axial load, which made the problem much worse. So I had to come up with a way to get the original spindle motor back on top of the mill and to power it. Mounting it proved to be the bigger challenge. I bought a cheap chain hoist from Vivor and then cut a hole in my garage ceiling so I could attach the hoist to a 4x4 going across the rafters. Then I hoisted it while my wife used her car to pull the motor away from the machine until it was in position. That worked great until the chain was fully retracted, but the motor was still a few inches too low. At that point, there was nothing else for it, and I had to use my big boy muscles to lift the motor above my head and onto its mount. I hurt for days after that, but the good news is that I'm totally jacked now. Then I had power to deal with. As I said, my garage only had 120 volt outlets, so my first order of business was to run a new 240 volt 30 amp circuit to the garage. That is a 4-wire circuit. Not only is that necessary for current codes, but it was also important for powering the quill motor, as you'll see in a moment. With 240 volt power available, I was able to power the spindle motor through a special VFD that converts 240 volts single phase to 480 volts 3-phase. Those are really hard to find, so I'll put a link to the one I bought on Amazon in the video description. Again, I'll go over the costs towards the end of the video. It was actually pretty easy to set up, and so far it's working great. Best of all, it gives me easy control over the motor speed, so I don't have to mess with the belt. With a twist of the dial, I can adjust the spindle from anywhere between 80 RPM and 2500 RPM. If I need a speed outside that range, and I kind of doubt I will, then I can move the belt. I can also easily reverse the spindle rotation direction, an important feature as you'll see in the demonstration later. The table power feed motor's VFD was also easy to set up. I didn't even bother with speed adjustment setting on the VFD since I have that gearbox for that. It just has a power switch. The quill power feed motor takes 115 volt DC, but there's already a rectifier circuit in the electrical cabinet to provide that. So I just kept that circuit in place, but it needs 110 to 120 volt AC power, which is why it is important that the 240 volt circuit was 4-wire. That gives a dedicated return path for one leg, so you can get 120 volts out of it. I wanted Gordy to look as pretty as when she was young, and visible VFDs would have ruined that. I shoved those in the electrical cabinet and repurposed the original switch panel to add VFD controls. There is a potentiometer for adjusting the spindle motor speed, a 3-way switch for off, forward, and reverse, and a 2-way switch for the table power feed. But wouldn't you know it, there was another problem. The spindle motor's VFD is real chonky, too big for the electrical cabinet door to close. I'm actually a little proud of my hacky solution, which was to cut out part of the door and weld a steel baking pan on there to give the VFD more room. I'm too embarrassed to show you my actual welding, but I covered the seam in JB Weld and then some Bondo with sanding and paint. It looks pretty good, though the paint color isn't quite right. Phew, that was a lot to get through. I appreciate your patience, you're very kind. But before we get to the good stuff, dealing with all of this milling stuff yourself can be a big hassle, which is why you might want to consider this video's sponsor, PCBWay. You may already know that PCBWay can deliver high-quality PCBs to your door, but have you heard that they also offer affordable 3D printing and CNC milling services? They can turn parts or mill in up to 5 axes in just about any material you could want. Titanium, for example, is notoriously difficult to work with, but PCBWay can do that hard work for you. Just send them your design and they'll do the rest. If you want to try it, use my link in the description to get a $5 credit towards your first order from PCBWay. Now that you know how I got it working, I can show you it working. I did some random tests, including absolutely plowing through some dainty 6061 aluminum, and then some slightly less dainty 1018 steel with a cheap 3/8 inch end mill. But I've been watching all the YouTube machinists that sit at the cool kids table, and they all have fly cutters. So I decided I needed one too. And I figured it would make the perfect demonstration for you all. My wife was kind enough to get me the fly cutter from Hemingway Kits for Christmas. Unfortunately, that requires turning on a 4-jaw chuck, and I only have a 3-jaw on my mini lathe. But I did have a carbide insert holder tool for my lathe that was too big for my tool holders, so I decided to use the material from the Hemingway kit to make a fly cutter of my own design that incorporates that. My first step was to turn that material down. You're here for mill stuff and not lathe stuff, so I won't bore you too much with those details. It was just a facing operation, turning a couple of diameters and then chamfering with a file. Now for the good stuff. I started by cutting a flat for the grub screws on one side of the fly cutter body. I have the body mounted at a 20-degree angle to give the carbide insert a good angle to the part surface. It really should be more like 30 degrees, but I didn't have enough room for that. I was able to use the table power feed for this cut since it goes straight across. I did this at the slowest speed, but really could have and probably should have done it at a much faster speed. It cut great, but you can see that the finish got messed up where I fiddled with the spindle speed part of the way through. When I came back for the climb finishing pass, it cleaned most of that up. With that done, I moved over to cut the slot. This was a really deep cut, almost a full inch at the deepest, at full width on the 3/8 inch end mill, but Gordy didn't mind. However, I made two big mistakes. First, I forgot to leave enough material for a finishing pass. Second, I forgot to lock the slide and the hand wheel turned, completely ruining that wall. What can I say? I'm very out of practice with manual milling, and I never had that much practice to begin with. I was always a CNC guy in the past because I was young and foolish. Anyway, this wasn't that big of a disaster because that slot width wasn't critical. That's because I had to shave down the insert holder to match the slot anyway. As you can see, I was removing a fair amount of material from the shank of that holder. As it was, if I put the insert in the center, there wouldn't have been much meat left for clamping with grub screws, so I just shaved off less than I originally planned on. I added a shallow pocket to the shank so that if the grub screws back out a little, they'll still catch in the pocket and the tool won't embed itself in my cranium. I also went back and cleaned up that slot off camera because it was mocking me. Then drilling and tapping for the 1/4 inch 20 grub screws. I really hate tapping with this crappy Harbor Freight tap wrench. A tap wrench and follower might be next on my list of tools to make. And then it was assembly time. Some blue Loctite to keep the grub screws secure, of course. Now for the exciting first test. You might recognize this piece of 6061 aluminum from my video about the Barker Mill CNC conversion. I started off a bit too deep. It was working, but I didn't love the sound of it, so I raised the quill a tad for a shallower cut. Once again, the table power feed came in really handy. I could just let it run while I stepped back and admired the cutting action. And it worked almost flawlessly. I probably could have sped up the spindle speed, but I still got a really nice reflective finish, and the chips were just about perfect for aluminum. Still, we all know that aluminum finishes are never very impressive, and I do want to impress you. So I also tested the fly cutter on a piece of improperly clamped steel. This is actually a cutoff from the body of the fly cutter, so in a way it's eating itself. Anyway, it turned out even better than I could have hoped. The finish is downright glassy and completely smooth to the touch. Therefore, I'm calling this tool a success. I'll put a drawing for this fly cutter on my Patreon in case you want to make your own. With you now appropriately awed, let's go over what I actually spent on Gordy and what I would have spent on a mini mill in comparison. I purchased the mill for $1,000. As I said, that included the delivery. I paid $75 to rent the pallet jack from Home Depot, and cleaning supplies cost me about $40. Installing the 240-volt circuit cost around $375. The spindle VFD was $474, and table feed VFD was $72. Random electrical stuff was probably another $30, and the chain hoist was $35. Then there is the vise. The seller included a Bridgeport vise that was beat to hell. I didn't want to deal with refurbishing it, so I sold it for $100 and then bought a Vivor vise for $126. so that's a net cost of $26. I'm not including the cost of end mills or anything, but I do feel like I should include the cost of collets, since these ZZ collets are hard to find. The seller included some to go with the collet holder, and I also bought a used set on eBay for $63. All in, that makes my total spent $2,290. Not too bad, but surely more expensive than a mini mill, right? Well, not so fast there, you penny pincher. First, there is a good chance your garage already has a 240 volt outlet, in which case you wouldn't have the expense of installing one. And if your mill's spindle can run on 240 volt three-phase power, then you can use a VFD that costs like a fifth of the price of the one I needed. But let's stick with the $2,190 price tag. How does a mini mill compare? I'll use prices from little machine shops, since that's the only place you can get a Sieg X2D in the US, and that's the most affordable fixed column mini mill. I'm going to do my best to get a one-to-one comparison here. The Sieg X2D itself is on sale right now and costs $899. You're going to need some R8 collets, and their basic set is $67. Shipping and tax are hefty, so together those come out to $1,298, at least to my location in Phoenix. For the vise, we'll use the same price as the one I bought, $126. But if we want to match Gordy, we're going to need power feed on all axes. The cheapest units I could find for mini mills are about $120 each, so that adds $360 to the bill. Finally, you're going to need something to put that mini mill on. I can't imagine you want to use it sitting on the floor. There are lots of options, including welding one together yourself, so we'll be conservative and call that another $100. So the mini mill will cost a grand total of $1,884 before tooling, or about 82% of the cost of this old industrial mill. Remember, if you get one with a 240 volt motor or don't need to run a 240 volt circuit, the industrial mill would probably be cheaper. But more importantly, the industrial mill is far, far more capable. It has a lot more rigidity, a lot more travel, and a lot more power. Am I saying you would be a dummy for buying a mini mill and that they can't do the job? Not at all. Blondie Hacks, for example, has proven that you can do amazing things with one, though she has an expensive Precision Matthews mini mill. Another favorite YouTuber of mine, Artisan Makes, also shows time and time again what you can do. But he also started with a better mill, the Sieg X2.7L, and heavily upgraded it with a much more powerful motor and rigidity upgrades. Even then, he has to take much lighter cuts than I can do with Gordy without even a hint of strain. Still, a mini mill may be for you if you have very limited space or simply don't want to deal with the hassles like what I went through. And though Gordy is in remarkably good condition, she isn't perfect. You may have noticed some brown oil in the fly cutter portion of the video. That's because the spindle oil is leaking. Probably a worn O-ring that I need to replace. Other than that, however, she is working great. The ways and screws all feel fantastic. At the end of the day, choosing between a mini mill and a used industrial mill is a hard decision, but I hope that I've given you some clarity. If you have the space for it and are willing to get your hands a little dirty, an industrial mill may be a great choice. It will likely be comparable in cost to the price of a mini mill, but will be much more capable. If you want a compact turnkey solution, you might be better off with a mini mill. All I can tell you for sure is that I'm happy that I chose Gordy, and I plan to keep her until I die, at which point it will be somebody else's problem to figure out how to move her. Now I just need to figure out if I'm going to replace my mini lathe with a used industrial lathe. The machine shop where I got Gordy did have an old Monarch they were looking to sell. Thanks for watching.